Welcome to the office. We want to take a look at an example of factor group computations here. But before we get started, I'd like to very quickly review a couple of examples that we've already considered. So here in front of us is the example that we would like to consider in a moment. But before this, let's quickly look at the examples that we've already considered. So we've taken a look at this example, Z4 direct product with Z7, quotient by this subgroup. What's generated by this is essentially something that's isomorphic to Z7. Right? So what's generated by this is all of the things that look like that, but that's all of these where n is in Z7. But this is Z7 bar, right? We took a look at this definition. This is a theorem that we have previously looked at. So when we take this direct product and quotient by something that is essentially Z7, then what we're left with, right, those cancel out and we're left with Z4. So that's very convenient and very nice. And I had hoped to provide something that was distinct from this in the example that followed. However, what it turned out to be is just the slightest variation, right? I'm not taking the quotient by what's generated by 1, 0. However, right, if I were taking the quotient by what's generated by 1, 0, I would have Z3 bar, and the result would be Z6, according to our previous example in the associated theorem. However, here it looks a little bit different, but only in that I'm not using the particular representation of Z3 generated by 1, 0. Instead, I recognize that this particular element, 0, 2, is order, right? So the order of 0, 2 in here is 3, which means that the subgroup it generates is isomorphic to Z3. So I'm taking Z3 direct product with Z6, and I'm quotienting by a subgroup that is isomorphic to Z3. So while I'm not quotienting by Z3 bar, I am still quotienting by something that is isomorphic to that. And therefore, the result we should expect to be Z6. So overall, the example is not significantly different than the previous, just the ever so slightest variation. This maybe would have been an excellent homework problem, but here it is posted, so excellent. What I'd like to do now is I would like to consider an example that is a little bit different. So we are taking just another small step because it's still taking the quotient by a subgroup that is generated by 0 something. But in this case, what's generated here is a subgroup of order 5, so we don't have that it's isomorphic to Z12, and we don't have that it's isomorphic to Z15. Okay, we still get some convenient scenarios or situations that we'll talk about here, but it is different than what we've seen in our previous examples. All right, so we're going to approach this example twice. Once here, where we use an argument to discuss what describes, actually here, just some extra words there. Use an argument that discusses what happens in the quotient. Okay, we want to describe what happens in the quotient. So in the quotient, what we're going to have is we're going to have that Z12 is essentially unaffected, right? So the first factor of the direct product is not affected in the quotient. So in the quotient group or factoring group. Because I'm essentially dividing by the identity, right? If I take something and divide by 1, I'm not changing it. Or subtract 0, I'm not changing it, right? That sort of idea. I'm not changing Z12 when I take the quotient. What's happening on Z15 then? Well, the subgroup generated by 3 is a subgroup of order 5 in Z15. So when I take this thing of order 15, right, Z15, and I'm going to divide by something order 5, which means that the result, 15 divided by 5, should be order 3, is the right idea. When we're talking about finite groups, this is perfectly fine. That is, in fact, we have that information. We used it in our previous examples. So we have a subgroup of order 5 in Z15. We take the quotient, we're going to end up with something order 3. So Z15, when we take this idea, right, we're taking more than just numbers. 15 divided by 5 is 3. We're taking these groups, these things, these objects, and we are collapsing them on themselves. So rather than just taking a number and dividing it by something else, we want to recognize that we're taking a pizza and we're cutting it into 8 slices, and we're saying all these slices are the same. So we have right, one version of it, or whatever the case may be. So 3 subgroup order 5 Z15. So Z15 is collapsed into this is of course a commutative group. Commutative group order 3. Now, sometimes we're collapsing into something that's not of prime order, and so the commutative comment might make a little bit more sense. Of course, a group of order 3 is commutative. There's no other possibility. All of our groups of order 3 are commutative. So if that's the case, since it's order 3, we know that what it collapses to is going to be isomorphic to Z3. Okay. Hence, we take this quotient, Z12, direct product with Z15, quotient by what's generated by 0, 3. This is going to be isomorphic to, okay, we didn't touch Z12, so we expect that to stay the same. In Z15, we're collapsing into a commutative group of order 3, so that should be isomorphic to Z3. And that's precisely what we're looking for. So with these two comments, right, the first factor is not affected. The second factor is collapsed into a subgroup or into a commutative group of order 3. Hey, commutative group order 3, that's Z3, no problem. And so that's a sufficient response. That's a sufficient explanation for what we get in that direct product. What I'd like to also do is take an argument that's similar to our previous example, where we look at the order of the direct product and the order of the subgroup that's generated, those sorts of things to create an argument of why it should also be Z12 cross Z3. So I'll see you back here in the office in just a minute for that example.